let's start. So this interview, the format of the interview is that
Mhm.
interview in total would be of 45 minutes. First would be introductions. You can skip your introduction if you want to, because you want
Okay.
to stay discreet. The second
Yeah.
is I'll give you a question. I'll tell you what the question is about, and then what we'll do is we will have a 45 minutes coding round, and then there will be a feedback.
Oh,
Cool.
yeah, sure. Okay.
Sure. So let's start. It's 16. Sorry, not 16. Sorry, 8 past 6. So 8 past 6 plus 45 minutes, whatever it is, we will have that much time. Right?
Yeah, sure.
Cool. So let me first introduce myself. I'm
Mhm.
Kaustav. I have been in industry for about 7 years now, almost
Okay.
7 years, I would say. So I started with TCS. There I was a web developer. I used archaic technologies like JSF, Java, and stuff like that. Then I moved to big
Okay.
data, where there we had Hadoop and Spark and big data technologies. I was, yes, like
Right.
I said, I was working as a data engineer there. Then it was a year-long gig. Then I changed the company, moved to Oracle. There I was working as an application engineer, and it was a full stack development role which I was doing there,
Right.
front and
Mhm.
back end and stuff like that. So I stayed there for like 2 years. Then I thought it's time, and I moved. I was looking for a job, and I got a place in Google. In Google again, I'm an application engineer. What we actually do is build internal tools for Googlers, and our area is around remote collaboration and supply chain management. So that's about me.
Right. Okay. Mhm.
So let's start with the question. This is so the interview would be so the question would be a two-part question. Okay.
Okay.
So we
Two
will
partners.
quickly do the first part and then we'll move to the next.
Oh, yeah, sure. Okay.
So this is the first question.
Okay. Mhm. So, given the root of a binary tree, determine if it is a valid binary search tree. A valid binary tree is defined as follows. The left subtree of a node contains only nodes with key less than nodes key. The right subtree of a node contains only nodes with keys greater than the nodes key. Okay. Both the left and the right subtree must also be binary search tree. Right. Okay.
Okay.
Yeah. Okay. So I'm just looking at the examples here. 213 is the output is true. So basically, I need to return a Boolean value if the given tree is a binary search tree, correct?
Exactly.
And these are the conditions basically. Correct.
Yep.
Okay. 5143. Correct.
So yeah.
Right. So I understand. I'm sorry. Am I audible?
Yeah. Sure. Please go ahead.
So from what I understand from this question is that we need to return a boolean true or false if the given tree is a binary search tree, and these are the conditions that we are given. Okay,
Right.
and we are giving, so basically binary search tree is that the left subtree, all the nodes in the left subtree contain value that are less than the current nodes key, right?
Right.
And similarly for the right subtree, basically all the values in the right subtree will be greater than the current node key, right? And
Right.
this will apply to all the nodes basically. So what I am thinking of here is that we can have a recursive solution here. Basically, you go to each
Mhm.
node and
Okay.
try to find out if it obeys the binary search tree, and in turn we will give calls to the left subtree and the right subtree basically.
Okay.
And what we will check in that recursive function is basically you'll have two values here, that is the minimum value and the maximum value. Okay. In each subtree I need to check if all the values are basically available within that range.
Okay.
For example, let's take the first example here, right? This is 213, right? So I'll call the function with by passing the root here. That is, I'll pass
Can
the
you?
2
So
here.
I cannot see where you're pointing. If you can move your cursor.
Okay, sorry. So this I'm looking at the first example here. Okay, I will pass the root of this node to my function, and I'll pass the minimum value as the integer minimum value and maximum value as the integer maximum value. I'll be using Java, so
Okay.
those values will be available to me, and I need to check that the current node is within the range that is minimum and maximum available here.
Got it. Got it.
And
So
then I will, yeah,
yeah, go ahead. Bro.
and then I will pass to the left subtree. I will search for the left subtree. In that case, the maximum will become 2 here, because the max all the nodes, all the values in the nodes on the left subtree will be less than the current node, right? So the maximum that can exist on the left is the current node, and similarly on the right subtree, it will become minimum basically.
Mhm.
And for each node that I traverse in the recursive function here, I will check that the value exists within that range. And if it does not, I can return a false directly from that point. Yeah.
Okay, makes sense. So, however, I have a question here.
Okay.
So, can you check the constraints of this question once?
Constraints. Okay.
Yes, and check going with the constraints if still your solution works.
Okay. The number of nodes in the tree is in the range 1 to 10 raised to 4, and node value is minus 2 raised to 31 and 2 raised to 31 plus minus 1. Um, okay.
If you think it does, then we can move forward. If doesn't, then
I think it should be possible. I'm not sure about how much the stack can take. Basically,
sorry,
when
the
you
stack.
call a recursive function, it will go on the stack, right? The stack of the
Right,
memory.
right.
So I'm trying to think if this range can fit on that stack or not.
You're not sure how much the stack size is it?
No, but I
Oh,
believe that
okay.
it
I
can
give
be
you,
done.
I give you this. Okay, let me just tell it to you straight. So, in Java, the stack size, as far as I remember, is either 7,000 or 8,000.
7 or 8 thousand. Yeah.
Yes, yes. Excuse me. Yeah, it is 7 or 8,000.
Okay.
Yeah,
Then right. Then my solution will fail. Will give a stack overflow for very large size of tree, basically.
right.
Uh,
So, what now?
okay. Okay. Let me think. Okay. Um, I need to check it's a binary search tree.
Right.
Another way that I can think is it's basically a binary search tree, right? Uh,
Yes.
so if I do a in order traversal,
Mm-hmm.
in that case, it will and the values that I visit in the in order traversal, if I keep them in a certain array, that array will always be in ascending order. That will be basically be in a sorted order. if it is an exact binary search tree.
Okay, okay.
Or another way is that instead of doing a recursion, I could also do basically a stack or declare a stack and do a uh, do a recursion using that stack basically. Uh,
So even if you do even if you do in order, that wouldn't that involve recursion?
in order can also be done using stack, right?
Okay,
Declaring the stack outside,
okay.
and
Oh,
in that case also it can be done.
okay, okay. Makes perfect sense.
Yeah.
So how are you going to do it?
Uh, okay. I'm trying to think. Okay. So if I do an order traversal without using a recursion, I will be using a stack. I'll declare a stack, and in that stack, it will basically move towards the left subtree always, and then to the current subtree, and then to the right subtree.
Hmm.
Okay. Um,
So you are thinking correct, Pratik. So the stack part
yeah.
may work. Why do you have any doubts why stack would not work?
Actually, I'm just thinking how I can code it up. Basically,
Okay,
I'm thinking of the implementation part. Stack will work.
okay.
Stack should. Yeah. So let's say I create an empty stack. So the first element that I put in is the root. I'll push that root into the stack, and then
Mhm.
I will keep moving to the left of the node, and all the nodes that I will visit, I'll put them in the stack again. Once all the left subtree is um, all the left nodes are visited, then I will pop the topmost element from the stack. Okay, and
Mm-hmm.
when I pop that out, I'll put that into an array basically. Okay, and then I will move towards its right basically. I will put the right element into the stack and again start putting the
Right.
all the
So,
left nodes. Yeah,
right, you are going in the right direction.
yeah.
So, tell me about this. When you said you would use a list, right? Why are you going to use a list?
Yeah. So my idea was that I could store the entire binary search tree and then check if it is in a sorted order, basically.
So, do you
Uh,
really need the entire list to check if it is in sorted order?
no, I actually just need I mean, as I'm doing the in order traversal, I just need to know that the next element that I'm visiting is greater than the last element that I have visited,
Right,
right? And in any case that if that condition breaks, then I can say that it's not in the binary search tree.
right.
It's not a binary search tree. Yeah,
Exactly.
right.
Makes sense.
So I'll not use a different array. Basically, I'll store the previous element. I'll initialize that previous element as the smallest number that's possible. And
Mm-hmm.
no, sorry, I'll initialize the previous element as the root. Oh, sorry. I'll do some initialization with the previous element, and whenever I am popping it out of the stack, the
Mm-hmm.
top of the stack element should be greater than the previous element. That's it, and I'll update the previous element to become the whatever that I popped out of the top of the stack.
Right.
There,
Like, exactly.
yeah,
Exactly.
right, yeah.
So,
So
are you not confident with the solution?
Yes, I am confident.
Would you like to code it now?
Yeah, sure.
Okay.
Okay, I'll start to code from here. Okay. I'll be basically using Java. So
Don't worry about dog capitalizing your first character. Don't worry about it.
okay, this is called as I'll consider this as a node. Okay, node root. I'll do some basic sanity checks. That is like root equal null. Then in that case, I'll return basically false. I'll return. Okay.
Okay.
And then I have to declare a stack of nodes. I call it as stack equals new stack. Okay. And I also need a previous element, right? These are all
Yeah.
integer values, right? I'm assuming they are integer values. Yep.
So I mean the constraints are there.
Yep. Yeah. 2 raised to 31 is integer, I think. Yep. I consider it as integer dot min value. Okay. Previous element.
Okay.
And I will put the stack that push the root element basically.
Okay.
No, sorry. Okay, sorry. I'm a little dicey on this one. So, okay, when I do a recursive code, I'd say I put the left elements in the stack, then the current element, then move to the right, all the basically the right subtree, right? Uh, actually, okay. I haven't used a stack based in order for a long time, so I'm trying to think here. Okay,
Sure, sure.
okay, just give me a minute. Basically, this will be while root dot left is not equal to null. That case, I need to basically push the while root not equal to null. Basically
Okay.
pushing the root here, and
Hmm.
then I move to the root dot left here. Okay, and this is all the basically the left subtree have traversed here, and now I need to pop the top of the stack basically. Okay, stack. Okay, I write a condition here basically if the previous element is greater than stack dot pop. Pop will remove the element and compare here. If the previous element is greater, then I'll return a false from directly from here. Okay. And if it's not, then what I need to do is I need to uh, stack dot push root dot right, the right of your, sorry, if stack dot, if it has a right node is not equal to null, has a right node, then I push the right node into the stack. Sorry, I need to make the root equals root, sorry, node current equals stack dot top. So I have the node here,
Okay.
and if the previous element, that is the current dot value, let's say call it as value here.
Mm-hmm.
Sorry, I'm getting
Not no problem. Just relax. Yeah.
if it is not null, then I current equals current dot right, and I'll push the current here,
Mm-hmm.
and then okay, uh, once I have the right node, I need to push all the left node again here. Current equals not null. Okay, just a minute. Okay, I push the right here. Okay, current equals current dot left and stack dot push current.
Okay.
Actually, yeah, I'm a little dicey around this in order without recursion. Actually, uh, okay, I have declared a stack. What is the condition that will come here? While root is not equal to null, I push the root and then move to the left. Okay. Then I'll pop the top of the stack here, and then I'll compare the previous element here. I also need to update the previous element here basically. So I previous element equals current dot value. This is
Mm-hmm.
updated here. Then I move to the right of the subtree. That is, I'll check if it's not null. And I'll push. Uh, okay, sorry. Previous element here. If current is right is not null, then I move to the right of it. I push the right element onto the top of the stack. Then I move to the right. And while the current is not null, I'll keep moving to the left again, and I keep pushing it into the, okay, and then what is the condition here that will come? Your stack is not is empty at the start here, so I cannot write whilst
If you see.
any node here. Okay, I could do that actually. Stack here, push the root here, and while stack is empty, while stack is not empty, while root is not equal to null, I'll keep pushing the root here. Okay, the root is getting pushed twice here actually. Oh, sorry for this. Uh, what will come here? Stack is empty. While stack is not empty.
So where do you think you're stuck?
Actually, I'm stuck on this condition here. What condition I need to put here? So I was thinking this one. That is, I put a root into the stack first, and then check while
So
it's not empty, right?
so Pratik, here if you notice, right? I get it how you're trying to approach it,
Right. Yeah.
and so the point is, root is the variable which you are considering as current while inside your loops,
Yeah.
right? So if you are considering root as the current element which you have in reference, right? Should you move out of that reference and consider a different variable as current variable? So what I'm trying to say here is why not just stick to one reference? Try to stick to one reference and see if that works for you. So the cur variable which you are taking here, it is basically nothing but the node which you have just popped out of your stack,
Oh, yeah. Right.
right? So uh, keep
Yeah. Mhm.
yeah, so, keep calling it cur. That's fine. But what I'm trying to tell you is that why don't you just keep referring to root, right? Just keep root as
Mhm.
the focus of your attention, and then try to do the rest of the part. I would say this part. Try to rethink this part. Maybe if you rethink this part, this your while condition here and your while condition here would simplify. Just reconsider. Do you really need to do this?
Right. Okay. Let me think here. Okay. So let's say I popped it out of this one, and right. Okay. I actually don't need it if I go again into the stack here. Right. I am taking a root here. Then while root is not equal to null, and I'm pushing it to do the root, pushing it into the stack. Then I'm moving to the left basically,
Right.
and at the end I am popping out the topmost element and I'm
Right.
checking this condition here,
Mm-hmm.
and then I'm updating this condition here, and then I need to do is move to the right subtree basically, right? I'll do a root equals root right, and when I come enter the re-enter the while loop here, the root will be searching for the right subtree here, right?
Right.
Okay, just let me rethink. Okay, just a
Sure,
moment.
sure.
I'm doubtful of this one actually. If I'm putting the root here, I'm also putting the root here again actually. Um, so I could basically move a root left and do a stack push here.
Mm-hmm. That's fine. Don't bother about it.
And I do a stack pop here. Yeah, I think this is good.
That's fine. That's fine. Don't bother about it.
Yeah,
Mm-hmm. So,
yeah, I guess.
do you want to do a dry run of your solution once?
Okay, so let's try with 2 and 3. Okay, so I'm pushing 2 here, and 2
Okay.
is not null. Then I push move to 1 and push
Mm-hmm.
the 1 here. Okay, and in this case, I will come to the 1 here, right?
Mm-hmm.
I'll get a 1 here. Previous element is not greater than the current value, so it will move here. This element will become 1 here and move right to the right. Mm, mm. Actually, it's not working here. So if root dot right is not equal to null, only in that case I need to move the root to the right. But in this case, it won't move to the right. It won't get a right here. And when I stack is still not empty here, right? White root is not null. There is no left here, so it will come to 2 here.
Okay.
I think I need this check as well here. Alternate.
Mm-hmm.
While root is not equal to left null. Like on the top of it, I think this should work, but I'm not very sure of it. I haven't executed this kind of code before.
So,
I mean, my initial approach doing recursive
so
was
the
quite straightforward, but considering the constraints it could create.
do you think this would work?
Okay, let me try. Okay, so I'll start with the sixth node here. I'll push the sixth node here. Root is not equal to null. That is 6 is not equal to null. Left is also not equal to null.
Right.
Then I'll do a root lot left basically. Then I'll push 4 and 3 here. This while loop will push 4 and 3 here. So And when I come out of this here, stack pop will pop out the three element here. Okay,
Mm-hmm.
and previous element I have initialized it to min value. So previous element is not greater than, so it will move here. Previous element will become 3 here. It does not have a right, so it will move back here. Okay, so in this case, the root is 3 here, right? Okay, 3 is not null, but three's left is null. So it will move out of this while loop here and pop the next one,
So
that is
how
4.
would it move out of this while loop?
Uh,
How would, when root is 3, how would it move out?
right, yeah. So doing a root dot left, not null, and then doing a root dot.
Quick time check. We have 10 minutes left. It's more like 9 minutes.
Yeah, in this case, it will do this. Yeah. So it will do a root dot left. In this case, it will become null because piece left is null, and then it will move out of the while loop. Then come here. It will get the 4 here. 4 is not less than 3, so it will move here. It will update this one. The right tree is not null, so it will move make the root as 5 here, and the stack is still not empty, so it will can go here. Root is not null. Consider the root left. 5 does not have a left here, so it will come out of the loop here, and it will pop the next element, that is 6, because 3, 4, and 5 have been popped until now.
Do you see what we have missed?
I
Did
am
we miss
sure that
anything?
I'm missing something, but I'm trying to.
You just, while debugging, you just missed something. You just missed it. I'm not sure if you
Right.
realized it or not, but there was a point. Yes, this was missed, right?
Yes.
Somewhere.
So I put the 5 here, right? Root equals 5 here, and it came here. Root is not null. 5 is not null. But root dot root left is. Yeah, I'm not pushing that to stack. Sorry. Yeah. So I pushed the 5 here, and I'm not checking. Oh, the 5 was pushed here, and when I did when I came here, the root was 5, right? So it came out of this one and popped to 5 actually again, and 5's right is not is null, so it go. I'm certainly missing here something. Uh, like how much time do I have left again still?
Six minutes. What do you think you're missing here?
Like it's not moving from 5 to it should move to 6 here.
Keep moving to 6.
Mm, Came to 5 here. Uh, so let's come back to here. 4, I'm popping out the 4 here, and then I'm pushing the 5 in this case, okay? And then I'm coming here, and it is coming out of this one, and I'm coming to 5 here, and then there is no right, so I'm again coming back to 5 here, and it's coming out of the loop here, and then I'm coming to 6 here. Yeah, it is working, but I still need to test it out on correctly actually. Yeah, I have yeah, I guess I took a lot of time just only on this question. There were two parts of this question, right?
Yes. No, no problem. No problem. It's just a mock. No problem.
Yeah, I think this is my code.
Good. Do you so just again do a code review, right? And tell me if something which you did, so if there is any mistake you did or you want to change, do a code review of your code as a code reviewer. I mean, how would you review this?
When you say view, does it mean like on the logic part or on the code writing part?
So when you do a code review, what all do you check? Just check everything, right?
Okay,
Those
sure.
things, whatever you check, right? And tell me about what are your comments as a code reviewer of a code, of your own code. So let's give it 2 more minutes and then we'll see if you have any questions.
Uh, Returning false here, creating a new stack here. Previous element stack or push root. Stack is empty. The dot left, the root is not null. Okay, method name is good. I believe it's returning the correct values here. I'm returning the default value here, and here. So okay, that's good. The name of the stack just I've given as a stack. I could change this to like in order stack or something like that
Okay,
to make it more, give it a more meaningful name.
okay, okay.
And while root is not equal to null, while stack is not empty.
Hmm. Okay, Pratik, let's stop here. Do you have any
Yeah.
questions?
Uh, any questions, Azin?
As in,
Like, could you tell me the second half of this question so that I could try on my own later?
so the second part of this was how would you balance it? How would you balance a binary search tree?
Balancing a binary search tree. That means you're creating equal uh, nodes in each of the subtree, right? That one,
Yes,
right?
right, right.
Okay. Okay then. Yeah.
Any other question?
Um. So I had one question. So the place that I got stuck, I mean, where I had changed my approach was due to this constraint, right?
Which constraint?
So, like you asked me that
Okay, okay, okay. Yeah, got it.
will my solution work with this constraint? So in that case, I did not know what the stack size in Java basically is. But what if the interviewer asks me the same question and I just say like, yeah, it will work? What happens in that case? Will the interviewer catch that, or would he, debate that? What do you think?
I'll cover that.
Yeah, sure.
I'll cover that
Yeah, I
after
think
the.
though
I'll
that
cover
was
that
the only
after
question.
this. So, any
Yeah, I
questions
think
about
that
tool? Okay. So
any
let
question
me.
of
Sorry, sorry. We are sorry. Please continue. I'll stop.
no, yeah, that were the only questions that I had. Yeah,
Okay, okay.
thank you.
Yeah. So coming back to the feedback, what I would say. Let me first tell you what you did good, right? What was.
Yeah,
So I really liked the part of your conversation. Right? You were
okay,
continuously communicating with me. Sorry,
okay,
you were continuously communicating with me, right?
yeah, okay,
And I knew where you were going wrong. That's a
okay,
good thing, right? I always, at every point of time, I knew where you were going wrong, and I could help
okay.
you whenever you were,
Oh,
right?
yes, you
Like
did.
I
Yeah,
did. So
yes, you
even
did.
when you
Yeah,
were thinking about your approach, you were pretty much vocal about it. When you were implementing a
yeah,
solution, I could literally follow each and every line which you were writing. And why you were
okay,
writing it, what was the approach towards by which you were writing it. I could follow it line to line,
okay, yeah,
right? And uh, since I could follow it, I could know why your solution worked or why your solution did not work or where your solution could fail,
right, yeah,
right? So that was a very good thing, right? Keep
okay,
it up. I mean, the way you're solving it and talking, keep doing it, right? Don't stop doing it. So the next part, which I liked a lot about is that the variable names were pretty good. Right? You did not
okay,
use you did not use any variable name which can get me confused. Next thing,
right, yeah,
when I mentioned that there is a constraint, so this is a bit negative and positive here. The negative part I will cover later, right? But the positive for
okay,
now. So the positive part here is that when I mentioned you that there is a range, so you considered it so you consider the constraint, right? You consider that okay, this may fail.
right,
You did not know what the range was, but you there was you said that it may fail. There is a constraint here that as the number of stacks increase, there would be an exception.
right,
So you did not know the range. So that is, I would say, uh, that is not a red flag, right? You may or may not know that. But one thing
yeah,
I would say that you could have mentioned uh, an estimate. What, in your assumption, what in your view the estimate would be? So,
I'm sorry, can you come again on the last part?
I would have what could have been done better here is that you could have said that uh, what estimate do you have of that range?
Okay, okay,
Don't have to be to the point, but like even I mentioned you, right? I said that it is either 7,000 or 8,000.
right,
So even I'm not sure, but it is somewhere around that. So you could have given an
Right.
estimate, right? It could have been 1,000, 2,000, maybe. So,
Right. Yeah.
right? So here you could have played with the condition that since you have given me this constraint,
Mm-hmm.
right? It means that the constraint has a
Yeah.
part to play in this question,
Yes.
right? So this could have been thought, right? Now, another point here is in an actual interview, you may or may not get this constraint. You have to think about.
Right. Okay.
But yeah, I will tell you what could have been improved. So I like the way when you got to know about the constraint, you could you could flex your thoughts, right? You could uh, change your approach. Then again, when you were
Yes.
going in
Yeah.
the wrong direction, I tried to help you. You were very quick in changing your solution, right?
Oh, yeah.
Your solution still had
Okay.
bugs. That's fine, right? But
Yeah.
you were going in the right direction. That's good, right? An interviewer would like that,
Right. Okay.
right?
Yeah.
So I think these were really good points from the interview perspective, and I think the solution would work mostly. There could be an edge case here and there, but the solution should work. It could have been a bit
Uh,
elegant, but it would work.
right. Yeah.
Okay, it should. So now the point here is what could have been improved. Right?
Yeah.
First, let's start with the first point, which I just discussed. You should have read the constraints.
Mm-hmm.
Right?
Okay.
You should have mentioned an estimate that I think it should be this.
Okay. Yeah. Mm-hmm.
That this assumption. So whenever you are doing recursion, right? Just
Yes.
throw it out. You know recursion would fail. There is a condition
Okay.
where recursion fails.
Yeah. Yeah.
Right? Clarify it at the front. I mean, clarify it at the very beginning. Whenever you are saying it's recursion.
Yes. Okay.
That
Mm-hmm.
what is there any constraints that this recursion can fail? I mean, just tell the
Mm-hmm.
condition with why would the
Okay.
recursion fail and ask them if that constraint is there or not. Right? You should do that always.
Right. I should. Yeah. Okay. Mm-hmm.
The second thing, uh, which was a red flag, not a red flag, but you missed this constraint is this the value of this node. Can you see my? Well, you can see where my cursor is, right?
Yes.
So
Yes. Yes.
this is integer min value.
Right. Yeah. Decent
Your
value.
your code would have failed if the tree had integer min value.
Mm-hmm. Right. Hello.
Yeah, I'm saying your code would have failed if your node would have had integer min value, right?
Yes.
Yeah.
Yes.
So there it would fail. The next
Yeah. Okay.
thing which I was expecting you to ask is that can two nodes have same values,
Okay. Right.
right? So if if in case the answer would have been yes, again your solution would have failed,
Yes. Yeah.
right? Or I mean,
Yeah.
it may or may not. This part of your this part
Yeah. That
may
would fail.
fail
Yeah.
if it is at
Yes.
towards the right or something.
Yes. That were equal. It would fail.
It may. I have to think, but yeah, I have to think about the. I have to try it, but I think it can fail, even if it doesn't fail. But I would like you to, Think about it.
Yeah, bring that up, right?
Bring
Yeah.
that up, right?
Yes. Yeah.
Then
Okay.
Shu said that if a root is null, you would be returning false.
Yeah.
It is kind of an assumption you're making,
Yes, that was an assumption. Yeah.
right? Just uh, put it there.
Yeah. Okay. Convey that also. Okay.
You should convey that.
Okay. Yeah.
The interviewer may expect you to throw an exception.
Right. Yeah.
Why not? I mean, don't do it in
Mhm.
competitive. You don't do it in lead on lead code. Doesn't mean you shouldn't be doing it, right? In
Right.
in,
Yeah.
in an
Yes.
actual data structure, you would always have exceptions thrown from your methods.
Right. Yes. Exception. So yeah, if I'm making any assumption, I should tell the interviewer basically
Exactly.
that. Okay. Yeah. Mhm.
So the next thing here is that um, your solution could have been more elegant.
More elegant. Okay.
Yes. How it could have been more elegant is that so when you add too many conditions, too much, when you
Mm-hmm.
do too much nesting, your solution becomes hard to read. Like
Right.
here.
Yes.
So this if and this if could have been avoided, I guess. Let's try to avoid it because if you do not if so you are checking whether the right is null or
Mhm.
not. You do not need to do that. You just see if the current root is null or not, right? You could have added this check here as well with your void, right?
Right.
Just work with the current value. You do not have to think about the future, right? Do not
Okay.
bother about the past. Just think about the current value, right? So
Mhm.
so just use that and play with them. It could have been better.
Yes.
Not a red flag,
Yes.
but yeah, it could have been better. So
Right.
these two things. Then another point here is although you improved with your consecutive dry runs. So yeah, before that, root. You
Mm-hmm.
changed root here, but you forgot to do it here and here.
Yeah.
Yeah, this is a small miss, but yeah, just make sure you are changing it
Yes. Yes. I should
everywhere.
have got that
Right?
actually.
When you're doing so, you did two dry runs, one code review. You should have followed.
Yes. Yes.
The next thing is when you wrote your solutions. So the first solution you did not you the thing which you did was this in this line was this root dot left. No assignment. That's it. Root dot left. Right, and you
Right.
did two rounds of dry runs.
Yes.
Right, and you missed it. And at the last, when you were thinking of when you were in the last dry run when you missed that five, right, then you fix
Yeah.
this. Right, so
Yes.
it is
Yes.
again. So again, while you are coding it, right, just make sure that you're aware of it. Not a big thing. I'm just nitpicking. Most of it, most of your interview was good. Just nitpicking.
Mhm.
And
Yes.
one thing in general is that you require more hints, bit more hints. Right?
Okay.
So this question, I'm assuming, is comparatively straightforward,
Yes, it is. Yeah.
right? Why? Because you just need to do an in-order traversal. That's it,
Right. Yeah.
right? You are just doing an in-order traversal, and you're not using recursion, but you are using
Right.
stacks, right?
Yes.
So again, an in-order traversal is more like a DFS,
Yes.
You're going deep down there and you're bringing up values, right?
Yeah,
So,
okay, right.
so yeah, I mean, I think it should have been more straightforward, and you could have worked with fewer hits. And
Yes, actually.
I would have
Yeah.
expected you to complete it sooner, right? So
Yes.
I wanted to I wanted to have around 10 minutes with the second question as well. Maybe maybe
Right.
not coded, but at least discuss at least 10 minutes with the second part of the question.
Yes.
Right? So
Yeah.
I would say things were good, not bad. Just work a bit on your speed. Even if you're slow,
Yeah.
that's
Speed.
fine. You can certainly increase it while practicing. By
Yeah.
practicing more, it's not a.
Yeah.
That's it from my side. Any feedback or questions?
No, I guess that was really good feedback for me. I do need to work on my speed and my debugging skills actually. Those were like very big, very good feedback that I got actually.
Yeah. So
And,
I'm really it was really good interview. Really.
yeah,
So
okay.
it was a good interview. There are things you can improve certainly.
Yes.
So the way I see it is you did not know how to do an in-order traversal stack,
Recursion, yeah.
without recursion, right?
Yeah, it
So
was like,
if I consider that, it is good, right? However, I may expect you to know it
yes. Yeah.
because using recursion is not so using recursion is very common when we are doing college courses,
Yeah,
right?
right.
When they teach us recursion, but when we actually do recursion, right? Sorry, when we
Mhm.
actually do an in-order traversal, something like an in-order traversal, we do not exactly uh, use recursion if we want to make our solution scalable,
Yes.
right? So I
It
would kind of
is.
expect you to know that. I may,
Right, yeah.
I may. Totally depends upon the interview. The interview
Right,
was
I.
pretty good, I would say. There were a few things here and there, but that is there in any interview. That's fine.
Mhm. Okay. I do need to study this actually.
Yeah, so study wherever you do recursion. This is one thing you can keep in mind
Yes.
in graphs or in trees, wherever you are doing a recursion, right? Make sure you do
Yeah.
some research and see if there is any solution which is there without recursion as well.
Without recursion. Yes.
Make sure that you
Yeah.
make a note of that and read about those solutions, those approaches as well.
Right. Right, right. Yeah. Yeah.
So,
So yeah, thank you.
uh, any feedback for me or any questions?
I'm sorry, can you come again?
I said any feedback for me or any questions?
No, actually, it was really good. I got to know a lot about where I'm falling short, and you did point out things that I had not noticed yet.
Mm-hmm.
Like, I mean, I always thought that my debugging skills were good, but when I did it with you, right, in front of you, so when you pointed it out, so I did realize that I was a little overconfident on that. So, yeah, thank you for that. And yeah, I did really enjoy this interview actually.
Thank you. Thank you.
Yes.
Thank you.
Yes.
Oh, bye.
Okay, then, yeah. Thank you.
Have a
Bye.
nice evening. See you.
Yeah, thank you. Best of luck.
Thank you.